What's up, YouTube? So for this video, I know it's been a little bit of time since I posted my last vlog from California. In that time, I was really thinking about what I do with this Circuit Playground Express and how I can really have it live up to its potential, and what I can really add to the series. And as I was thinking of like different projects I could do and different capabilities I could capture of this Circuit Playground Express, it really hit me that I have captured almost everything like that there is to capture. So with the Circuit Playground Express, this like series has almost done what I hoped it would do, which is introduce one to myself and also to everyone out there on YouTube just how this works and the basics of electronics. And I was able to cover the sensors in the first videos and then be able to connect those with other devices, as well as digital and analog outputs and inputs, and create a lot of projects using all the different aspects that this Circuit Playground has to offer. So for this video, I was really thinking about how I can encapsulate everything, and I thought about using something that would be something that everyone could use in their daily life, which is a smartwatch. Now, of course, it's not going to be as smart as like an Apple Watch or a Samsung Watch or something along those lines, but with this Circuit Playground, it has a lot of features that can make it a pretty smart watch, and especially when you combine that with, for example, a pulse sensor like this that you can get from Adafruit that measures heartbeat. There are a lot of different things that you could add in order to make it really complex and really robust really quick without spending a lot of money, as well as having a lot of fun with it. And this will review a lot of the concepts throughout all the videos. I'll be using a lot of buttons, NeoPixels. I will be using a lot of sensors and connecting and reading digital and analog outputs. And so I was thinking that this would be a great way to finish out the project and the series, I guess, with a all-encompassing project. And this does not mean, of course, that this is going to be my last video on the channel. This is just me ending the Circuit Playground series, and of course I will still be using the Circuit Playground, but there will be more, I guess, project-based instead of learning-based now that we've like understood the basics and all of that good stuff. So without further ado, let's get started. So before we really get into making the watch or going into the code for the watch, this is going to be something that I just want to go through real quick. This is the Arduino IDE. So there are 3 ways to program a Circuit Playground Express. One of them is with MakeCode, which we did in the first videos. The second one was CircuitPython, and this one is Arduino IDE. Unlike CircuitPython, which runs with Python, this is a program that runs with C++, and it is the native version or the native language for Arduino. So a lot of Arduino boards run with this, and allows you to really go deep into the system to have a lot more precision in your programming, but it is a little bit more complex. So I just kind of did a couple of things before I get into the code. One thing to do is make sure that you have your board manager downloaded, Adafruit SAMD, and you have to download this from a zip file, which is something to keep in mind, which you can download from the Adafruit website, and there are instructions on the Adafruit website on how to download it. And then once you do that, you just select your board, and then that's really all you need to do. So that's one of the things that is important. The other thing is, when you download that, you will have to also include libraries, and here I think just adding the Circuit Playground library will allow you to get everything that you need. It'll also ask you to download the library, but if you need it, just go to the Manage Library section, and then it'll give you a pop-up, and the rest will be easy from there. And then once it gives you that pop-up, just search up Circuit Playground. So that's really a little bit of kind of how you get all the wires and libraries that you need. these two are included, of course, with the circuit playground itself. So what is the code doing? Well, first we're including the circuit playground library here, and then we're also including the wire.header library and the spy.header library, and these are both C++ libraries. Then we begin the serial, so here you need to begin the serial in order to print to it. We begin the circuit playground and we set the pixel brightness to 100. And then after that, this is where we get all of our data. So we get the X value from the accelerometer by calling motion X, Y value is motion Y, Z value is motion Z. We get the light value with light sensor, the temperature with temperature F. If you want to get it in Celsius, you just do temperature. And then to get the booleans for the left button, you just search up left button, and right button is right button. And then I just say if it's left button, make it red. If it's right button, then make the pixel with the index 0, make that green. So after that, I just print out X, Y, and Z values. I print out the left and right button values, and the temperature and the light. And then after that, I delay it for every 50 milliseconds. And then I clear the pixel with index 0. So this is a pretty simple code, but it really allows you to understand what is going on, how you can get the different values from your sensors. So I am just going to plug this in real quick, just so y'all can see. So we have it here, and it's going to connect. And what you want to do right now is it's going to say Adafruit Circuit Playground Express down in the bottom, and you're just going to upload it. And then it will be looking for that Adafruit Circuit Playground Express and uploading to the board. And once it gets that, we can, I'll just demo it real quick and show you how the serial is going as well. Alright, and so now it found the port and it is now running. So it is done uploading, and if we look at the serial net value, now it is uploading a lot of different values. So you're going to see that it comes in rows of 4 every print statement, and it's going a little bit fast, but I'm just going to kind of show. So the accelerometer values are at the top, then the left button is 0 for false, and then 1 for true. Same with the right button. The temperature is the temperature in Fahrenheit. It's currently 92 degrees, and then the light is the amount of light value that it senses. So just now I'm going to put the light out, and now when it's in the light, it is at 95. So we can see it here. Pretty good so far. And so if I move it, you'll be able to see that the accelerometer value starts to go really, really fast, really, really crazy, and that's by design. And you can use this to really get a lot of motion functions, and which will be helpful while we're coding our smartwatch. Now I'm just going to show the buttons as well. So when I press the right button, as you can see, it's 1, or the left button, sorry, it's 1, and it does red. And when I press the right button, its value is 1, and it shows green. And if I do both, it is red. So that's just something cool to keep in mind, and I think it does this based on whichever one is pressed first. So yeah, it's pretty cool, and they both show 1 there. When I cover up the light sensor like this, you can see that the light is very low, 16, 17, and when I leave it out in the open, it's very light. Like, there's a lot of light. So temperature right now is 95, which is pretty hot, but that's just kind of how it's supposed to be, and it's reading it pretty well. It's pretty stationary around 95, 94, and I believe that's also because I was covering it with my hand, so it's something to keep in mind as well. And yeah, this is basically getting all the values that you would in Python, CircuitPython, and also make code in a very easy way. So you just include the library, you just begin it, the Circuit Playground Express, and then you just keep going from there, and you can use those values however way you wish. So now that we've kind of showed the Arduino IDE and how it works, I'm going to begin building the smartwatch actually. Alright, so in order to start building the stopwatch, we first need to upload the code to the Circuit Playground Express, because the way the stopwatch is going to be working, there won't be a USB port to connect to it, which means that all of our code must be written beforehand so that it can be uploaded to the stopwatch, and then that can just be connected to a battery as its power source. So I'm just going to kind of first go into a little bit of basics of just building the Circuit Playground Express and adding the pulse sensor to it, and then I'll go through the code and kind of demonstrate how the Circuit Playground Express looks and works. So we have our Circuit Playground Express here, and there might be a little bit of lighting up during some parts of this demo, but we will connect the purple wire. This is our analog input wire, so it gets the data from the pulse sensor. That will go to A0, like so. So that's at A0. And then we have our brown sensor right here, and the brown wire is connected to the ground, so that will be connected to ground on our board as well. And then lastly, we have our yellow wire, which is connected to the red, and that will be connected to 3.3 volts right over here. So as you can see, we have 3.3 volts, A0, and ground all connected with alligator clips. And so now that we have this connected, we know it's connected because the pulse sensor is green, as you can see here, and that just means it's turned on and it's reading values, and it just measures the amount of green light that it sees. So now I can kind of turn on the serial monitor and look at the code. Right now it's staying constant at 131. If I do something else with it, alright, it's at 131. We'll look at that a little bit later, but for now, just going through the code, it's very similar to the first one, where you have just a bunch of, here, let me turn off the serial monitor for now, where you have a bunch of libraries that you're including. It's the same libraries. Then you set the boolean for the temperature. There's the A0 pin, so this is the purple pin, this is A0 right here. We have our signal int value, and then we have our threshold, which is basically what determines a heartbeat, what A0 value would determine a heartbeat. Then we have our first temperature, our first movement, our first light, and our first heart, and our last time. So this is basically seeing what was called last time in order to see if it should stay the way it's kind of working right now, or if it should change up a little bit. Then we have serial.begin 9600, and then we begin the circuit playground, and we set the brightness to 100. So good stuff going on there. Loop, same thing. We get all the data from our different sensors, and then we say if the left button is pressed, then the temperature is true. If right button, temperature is equal to false. If it's in the temperatures, it will show the tens digit of what temperature it is. And you do this by setting the pixel color of the index I, which can be from 0 to 9, and we're doing it from every 1 to the tens value. So it'll basically set every index going up. So if it was 8, it would set indexes 0 through 7, which is 8, which will show 8 neopixels lighting up. And then if it's if tens is less than 4, then it'll become blue. That's just what I'm doing here. And then else if y is greater than 4, so if the acceleration due to gravity is greater than 4. And I also probably should put, now that I think about it, and y is also less than -4, just in case if it's the other direction, then it'll turn orange. Then else if the light value is less than 45, which means it's really dark, it'll turn on the bright light mode and everything will just show white. And then else if it reads a signal that's less than 700 but higher than 500, it will turn on the pulse sensor, and that will kind of pulse just to show that your heart is beating. So it will beat as the lights will flash as your heart beats. These are just some things to print into this monitor just so I can be able to track and troubleshoot. And then the delay of 50 milliseconds. And then basically I'm saying if you had the first temp and the last temp. So if it's a continuous kind of being called upon, if in this run temperature was called, and also in last run the temperature was called, it would be a constant movement instead of right here being cleared. And then I just set the first temp if it was first temp. So if it was temperature was called this time, it'll be kind of stored for next run in case the light will turn off. And we just set the brightness to 100, and there we go. So it's some pretty easy, nifty stuff. Pretty easy once we kind of establish the basics of how to get data from the Arduino IDE. So I'm just going to save it right now. And then let's get the serial plotter. Oh, the serial monitor is open, so let's look at that. And what I'm going to do is upload it, and then once it uploads, I'll just kind of go through it with the circuit playground here. Alright, and it uploaded. I'm not gonna lie, I did make one change that was really quick, so I'm just gonna go over that. One really small change and then one a little bit larger change, but they're both really easy fixes. So here I noticed that it was a little bit, when I was doing the accelerometer values, it was just reacting really quickly to the movement, so I made it a little bit more, how should I say it, just a little bit less, I guess like easy to change, or I made it a little bit harder to detect the movement by upping up the parameters for the accelerometer data. And I also, instead of making it 2 ampersands, I'd made the or sign, so it's saying it either has to be greater than 7 or less than -7. And then here, for the light sensor, I changed the set brightness to 255 just because that was kind of interfering with some things. So yeah, now that it's kind of working, I just wanted to show that real quick. So this is going to be something that I have to do in the engineering, but I'm just going to make sure that the pulse sensor is on me in such a way that I will be able to get values that are in the range that I want. So, alright, there we go. There's a circuit playground. And normally this would be a little bit more stretched, so I think we got it. So my heart is beating pretty fast right now, probably because I'm just trying to make sure that this all works, holding my breath in, a little bit scared just in case if it doesn't work, but looks like I got it off me. But as you can see, it's beating and it's noticing when it's going up and down and up and down. And then the other features of this, of course, is the light sensor. So if I cover it up with my if I cover this up with my finger, I should be able to show it. Let's see. Let me turn off the serial monitor real quick. I see what happened. So this is the temperature one right here, and basically you press the right button to enter the temperature, and then now that I've exited it, it's in the accelerometer mode, indicating motion, and it's moving and it's doing some good stuff. And then let's say I don't want to have motion, I just want to have just a light sensor that I can cover up with my finger, and you can see, hopefully, the light kind of comes a little bit, so you can see that bright light shining through. and that's just going to allow for like being able to see in the dark and things like that nature. So yeah, that is just kind of how the code works. And I know there were a little bit of tweaks and stuff. One of them I just hit the button, and then the other one for the heart rate monitor, that's just me trying to program it just right, where it is robust enough to get a lot of heart rate values, but it's also not too robust where it doesn't beep at all. And that's really going to come in with the engineering. So yeah, now that we've got the code ready, let's build the watch. Alright, so now that we've got the code, it is time to build the actual watch. So in order to build the watch, I made this sample watch face out of cardboard. This will get the job done. It'll just be face down like this. I have a little bit of tape. We've got some scissors here to just cut it, and anything else that might be needed. We got a wrist slap for just the band itself, so that, as you can see, it's able to go around the wrist, and it's actually like a watch. And I know it's a little bit of a more eccentric design, but you know, whatever you can get from Target, that's what you get. So yeah, and without further ado, the last thing that we really need is the electronic circuit with the Circuit Playground Express attached to the pulse sensor, and of course our battery pack right here. This is going to allow us to run the code on this bad boy without having to connect it to the computer. So yeah, let's get started. And all right, so I have the watch done and completed. It's a little bit on the futuristic side, but let me just show how it's looking. So I'm just gonna get it into a little bit more light. There we go. So this is it, beating to my heartbeat, which is really great. That's amazing. It's got the battery pack here. It's got the watch holder. And I taped this, of course, to the bottom with the pulse sensor sticking through. And yeah, right now it's just beating to the heart, to my heartbeat. And then if I go into somewhere dark, it will go into light mode. If I start moving really fast, here, in a more lighter area, like moving my up and down, as you can see, it also goes orange. So this will be helpful, I don't know, if you're trying to count reps or something along those lines. As you move up and down, it begins to turn orange. And of course, if you would need to get the temperature by pressing the left button, right there, you get your temperature. And on the right here, you are able to return back to your original state. So yeah, it was honestly once it got together, the project was very easy to program, really easy to design, and it looks pretty cool on my wrist as well. Yeah, we're bringing in the new age. So yeah, I mean, this has been an amazing experience, and I hope you've enjoyed as I've kind of gone along these Circuit Playground adventures. I would never have thought when I first made this that I would actually be programming, smartwatches like this, and to be able to do that brings so much joy and happiness, and it's just been amazing to share it all with you. So this is going to be probably my last Circuit Playground adventure, and yeah, peace. It's been a great one.